to our topic of linear equations containing fractions. Here you will learn to combine algebraic fractions using LCM as well as solve linear equations containing fractions either by cross multiplication or multiplying both sides by the LCM of the denominator. Display clean and coherent structure when solving these math problems. Okay, so what do we mean by this? Take for example an equation that we can have here. AB equals C over D. What can we say about this equation? Well, this is an equation that appears as one fraction equal to another fraction, which can be easily solved by cross multiplying or transposing. So let's do our cross multiplication. I would encourage that you keep consistent with your steps. So we'd say A times D will give us AD equals B times C, CB. Now we want A by itself. In this case, let's solve for one of them. So that's A. So we divide both sides by D so as to isolate A by itself. So by dividing both sides by D, we end up with AD over D equals CB over D. So the D's cancel out here. So use that red pen there. Cancel out, leaving us with that solution. So our solution will then be A equals CB over D. That's your solution for that particular equation. This is given that one fraction is equal to another fraction. Okay, now other times we have other types of examples. So you will be able to solve for some of these by going to the link on the group chat. Right now, let's do another type of example where we have fractions, an equation that appears with more than one fraction on the same side of the equal sign, or fractions on either side of the equal sign. So let's look at one example. Example 2. X over 3 plus 1 over 5 equals negative 1 over 15. Here, we'll multiply each term by the lowest common denominator so as to solve it. How do we do that? Multiply both sides by the LCM. So LCM of 3, 5, 15 is 15. By multiplying both sides by the LCM, then our equation will look as 15 open bracket x over 3 plus 15 open bracket 1 over 5 equals 15 open bracket negative 1 over 15. By multiplying this out, notice that these numbers are the ones which you will work first with so as to get lone whole numbers. So 3 into 3, 1, 3 into 15, 5. That gives us 5 times x, 5x. 5 into 5, 1, 5 into 15, 3. That will give us 3 times 1, 3 equals 15 to 15, 1. And then this 1 times negative 1, negative 1. So we are left now with one variable. We can now easily solve for this by subtracting both sides by 3, because we want to try to get to this one here by itself. So subtract 3 to both sides. 5x plus 3 equals minus 3 equals negative 1 minus 3. So this cancels out, leaving us with 5x equals negative 4. Now this looks like multiplication now. So how do we get rid of this coefficient which is in front of the x? Simply by dividing by the coefficient value. So divide both sides by 5, which is the coefficient. And if it was a negative, you will divide by a negative 5 in this case. But in this case, it's a positive 5, so we divide both sides by 5 over 5 equals negative 4 over 5. 5 here cancels out, giving us x is equals to negative 4 over 5. and that's our solution. In our next video, you will go through box substitution. Remember, at this point, leave it as this, because for box substitution, we need to substitute it into this equation, into the original equation, so that we can do our box substitution.